So Barb, reading about your work about stress cardiomyopathy really got me thinking, especially since it happens in so many other animals, what's the weak spot? Why did natural selection leave a weak spot, almost a literal weak spot, in the ventricle so you can get a sudden surge of adrenaline and other kind of things? It just can't really handle it sometimes. Is there some kind of benefit from having the system tuned so it's right on the edge of that kind of failure? What do you make of that?
Well, that question exposes why it's so crucial that we take an evolutionary approach to thinking about heart disease, and particularly this syndrome of stress cardiomyopathy. Because if you ask the question, well, I mean, how could having acute heart failure, which is fatal 3 to 5% of the time, be adaptive?
Not useful.
That doesn't sound very adaptive, and of course you'd be right. But if you have comparative knowledge, that is, if you're aware that this syndrome occurs not just in humans and not just in other great apes and not just in primates, but then in a wide range of mammals and reptiles
and they don't eat hamburgers
fish,
or smoke cigarettes either.
That you begin to it puts you in a position to begin asking questions about why this vulnerability might exist. In other words, what aspect of the vulnerability to stress cardiomyopathy is adaptive?
I'm going to guess you're going to spend the next 10 years working on this, but I'd like to hear briefly where you've come out so far.
So one way to answer the question is to say, one hypothesis that I have is that for certain animals under certain circumstances, having a robust, that is an explosive adrenaline, we call adrenaline catecholamines, having an explosive adrenaline response to threat, to danger, to a nearby predator is very fitness enhancing. It's highly adaptive.
So I can see this leads to a very specific hypothesis. Those species, I'm just going to guess, and then you're going to tell me if there's anything to it, those species where you might need that sudden burst to escape a predator or something should be more vulnerable to this. And those that don't, of course it could be the other way.
Right. Well, exactly. So that's why, that exposes why it's important to develop hypotheses, to have this comparative knowledge. And then that allows you to have hypothesis one. Species who are in an ecology with greater predator density might have enhanced vulnerability, or perhaps they would involve reduced vulnerability, resistance. So we need to have...
It creates a new question now.
It creates a new question. And importantly, it is a question that you cannot come up with unless you have this comparative phylogenetic information. And that's one part, that's looking between species. But then looking within species, that's really the question that physicians need to look at, because physicians are doctors entrusted with the care of one species, Homo sapiens. And we need to ask, within a population of human beings, which ones are vulnerable and why?
So for stress cardiomyopathy, I've been curious, is it really older women who are not in very good shape who are especially vulnerable, or is it just older women in general?
Right, so I can't answer that question specifically.
But next week I bet you'll be able to.
But one of the ways to penetrate that question and to use this way of thinking, this kind of eco-evolutionary way of thinking to help penetrate it, is to begin thinking about life history. So as physicians, we don't usually think about life history, but ecologists and evolutionary biologists, they do. They ask questions about how early exposures and experiences, and by early I mean sometimes gestational early, and early life exposures and experiences shape and frame behavior and physiology, that is phenotype, later in life. And that is a very eco-evolutionary way of thinking. Well, in the case of something like stress cardiomyopathy, I'm very interested in how the autonomic nervous system, that is the part of the nervous system that really has a big role to play in this disorder, how that might be shaped and toned and affected by early experiences, by stress, by the stress of the mother during gestation. And so we then can begin to penetrate the question intra-species, that is within Homo sapiens, the question that's relevant to physicians, by, again, reaching into the world of evolutionary biologists.
You're really using all four of Tinbergen's questions. This one's ontogeny or development.
Yes, that's correct.
You've been talking about phylogeny.
That's
You've been talking about function. And you've been talking about
adaptation.
mechanism. I think I'd like to ask you in just a minute about Tinbergen's questions.
Okay.